Hey everyone, and welcome back to The Explainer. Today we are diving deep into the super fast-moving world of AI and software engineering.
We are. We're going to follow the trail left by 4 fascinating new papers that really chart a course for AI. We're talking about a journey from AI being a simple coding assistant to something much, much bigger. From just evaluating snippets of code to autonomously creating entire software projects from scratch.
Right, and for a lot of developers, this isn't science fiction, it's their daily reality. So many people are already using tools like GitHub Copilot, and it really does feel like having a helpful Copilot right there in the cockpit with you.
But the research we're looking at today asks a much, much more ambitious question.
What if the AI wasn't just helping you fly the plane? What if it could be the pilot, the navigator, and heck, even the architect who designed the plane in the first place? That's the trajectory we're exploring today. So let's dive in. Okay, so first things first, we need a bit of a reality check. Just how good are the AI models that we can run ourselves, on our own computers, compared to those giant cloud-based ones? And that's exactly what the paper, Evaluating the Limitations of Local LLMs by Kadin-Meteltic and his colleagues looks into.
Okay, so hold on. Why is that distinction between local and cloud models so important? What's the big deal?
Well, it really boils down to privacy, cost, and control. Using a cloud service means you're sending your code, your secret sauce, to a third party. And for a lot of companies, that's just a complete non-starter. Running a model locally keeps everything safe and sound in-house. That makes a lot of sense. So how did the researchers actually put these models to the test?
Oh, they really threw them into the deep end. They took 8 of the most popular open source models and pitted them against this huge collection of over 3,500 competitive programming challenges from a platform called Caddis. And then, of course, they compared the results to the big players, the benchmarks for giants like GPT-4 and Gemini.
And what was the verdict? How did our local heroes do? Well, this is where it gets really telling. The results show a pretty significant gap. The absolute best-performing local model, a model called Q-Twen 2.5-Coder, had a success rate on its very first attempt of just 5.7%. And to give you some perspective, the paper itself notes that this is, and I'm quoting here, approximately half the pass-at-one rates of ChatGPT and Gemini. So the crucial takeaway here is that local models are making huge strides for sure. But when you get to these really complex tasks, there's still a very clear performance gap. They're not quite ready to replace the state-of-the-art just yet. Right. So once we have that baseline, the next logical step is to make the AI a better, smarter assistant for the tasks developers do every single day. And that brings us perfectly to our second paper, CodeRAG by Sheng Zhang and a team from XMN University, which is all about improving code completion.
Exactly. And this is where things get really clever. Instead of just trying to make the AI bigger, they focus on making it smarter by giving it better information. They use a technique called Retrieval-Augmented Generation, or RAG for short.
RAG, what exactly is that? The best way to think about it is like an open book exam. Instead of relying only on what it's memorized during its training, the AI can actually look up relevant code examples from the entire project repository before it tries to complete the code you're writing.
Oh, that makes so much sense because, a single file almost never has the full context. So how does CodeRAG make this whole process better?
It introduces 3 key innovations that really solve some of the most common problems in this area. It just makes the process smarter from end to end. First, it uses what they call smarter queries to figure out the most important parts of your code to even search for. Then, its multipath retrieval looks for context in 3 ways at once: by keyword, by meaning, and by how data flows. Finally, it uses aligned re-ranking to sort all those results so it can perfectly match what the AI needs to see to generate the best code. Okay, wow. So if our first paper was about the quality of the bricks, this is like giving the builder a whole set of laser-guided power tools. It's a much more sophisticated approach. Exactly. And that brings us to the most dramatic leap yet on our scale of ambition. We're moving from AI as a tool to AI as an autonomous agent that can manage a project or even build one from nothing.
Okay, now this is where things start to feel like science fiction. Let's start with the first of our 2 papers in this section, OpenLens AI by Yuxiao Chang and Jinli Suo.
So get this, OpenLens AI is a fully automated research agent designed for health informatics. It can take a research question, go review the literature, analyze data, generate code, and write a publication-ready manuscript, all on its own. Wow. Okay, so this is way more than just coding. It's managing an entire research workflow from start to finish. It can even understand charts and figures. That's a huge step up.
It really is. This is the AI as agent stage. But as impressive as that is, our final paper scales the ambition even further. We're going from managing a project to creating one out of thin air. It's called RPG, a repository planning graph for unified and scalable code-based generation by Jane Lowe and a team at Microsoft. And they introduce a framework called Zero Repo
Okay, zero repo. And what's its goal?
to generate a massive, complex, multi-file software repository completely from scratch based on a single high-level request, like, please generate a machine learning repository.
So the secret sauce is getting the plan out of plain, ambiguous English and into a structured graph that the AI can reliably follow without getting lost?
Precisely. This repository planning graph, or RPG, becomes the master blueprint. Zero Repo builds this graph first, defining all the components and how they connect, and only then does it start writing the code, function by function, with testing at every step.
The results must be the real test, so how did it actually do?
Well, on their benchmark, Zero Repo was able to generate repositories with an average of nearly
36,000 lines of code. And this really just perfectly illustrates the staggering difference that this kind of structured planning makes. Whoa, that is an absolutely astonishing difference in scale. It's not just an incremental improvement, it is a complete paradigm shift. This isn't a co-pilot anymore. This is the AI architect and the robotic construction crew building the whole house from a single sentence. Okay, so let's just recap this incredible journey for a second. We started with local AIs that were barely passing basic coding challenges.
Then we saw how much smarter techniques like RAG could transform them into these really powerful, context-aware assistants.
And we ended with autonomous agents that can literally build entire software repositories with tens of thousands of lines of code all on their own. You know, the common thread that connects all this progress is the move away from simple one-off prompts and toward more structured, persistent ways of representing a project's goals, just like that repository planning graph. That really seems to be the key to unlocking this massive leap in scale and capability. Which leaves us with a final and pretty massive question for the future. It's a huge question, and on that note, that's all the time we have for this explainer. Thanks so much for joining us.
Thanks for tuning in. See you next time.